So, how are you?
I'm fine. How are you?
I'm good. So we're here to talk about Surds then.
Yeah. So let's
Yes,
start without wasting further time. Let's start. So now in this case, the very first thing that I would intend to know here is what is a surd?
that I haven't. I don't really know. So it's something we covered very briefly, a while ago, which I don't understand. So I've completely lost memory of what it is.
Okay, can you give me a broad classification of surds? I mean, it comes under which head?
Um, is it uh, would it be algebra maybe? No.
What if I say that it comes under the head of numbers? Let me
Uh,
prove it. Let me prove it. So now in the next 15 to 20 minutes, I'll take you through surds. While going through surds through me, try and recollect whatever would have been told to you in the past. Maybe there would be certain things which wouldn't have been told, so you will come to know for the very first time, and the things which would have been told to you and which would be reverberated by me. I hope it makes sense.
yeah.
Okay, so I'm just sharing my screen. Uh, can you see something now on the board that I have
Yes.
shared?
Yes. I can.
So now let us say a real number. I
Uh,
am taking few examples here. Let's say the examples that I'm taking here are, for example, if I talk about this
yes. Now.
representation.
Now I remember. It's a number that when you square root, it doesn't come out with an integer or a whole number.
Okay, so let's stick to what we discussed at the very outset. So let me take another 15 minutes to make you go through surds. What is the objective? The objective is to first thing is that maybe you'll be able to recollect what you have already done in the past. That is the primary objective. The secondary objective is to make you go through those things even which you wouldn't have gone through.
Yeah.
The overall objective is to build up the fundamentals. That is the overall objective. Okay. So starting off now, if you would see the first column, I am referring to the first column. Can you see my cursor as well?
Yes, I can.
So I am referring to this first column, then I'll refer to the second column, and then maybe I would wish to take it forward in the third column. Now,
Okay.
I call square root of 2 as a surd. At the same time, I'm calling square root of 3 also as a surd. At the same time, when I refer to this number, which is square root of 4, till the time I write a number under the roof of a root, I call it as a surd. I repeat, if I'm writing a number under the roof of a root, we call it as a surd. We are not interested in knowing what exactly it results into. We are interested in understanding as far as the representation of the said the number that is being discussed is concerned. So you would see whether I write 2 or I write 3 or I write
Mm.
4 under the roof of a root, which is an operator, you would see that all these three representations, square root of 2, square root of 3, and square root of 4, is nothing but a real number which is written under the roof of a root, is
Mm.
a surd. So let me make a corollary here. And the corollary is, if I say a real number written under the roof of a root, am I given to understand that this is what a real surd is? Of course, absolutely correct. So we are saying a real number, I repeat, a real number written under the roof of a root is a real surd. Having said this, do we have only real surds? No, we have non-real surds as well. But the agenda of this discussion of around 15-20 minutes would be to focus only on real numbers, not on non-real numbers. Do we have any terminology like non-real numbers? Yes, we do have. What are those? We are not going to talk about it in this. Make sense, Pransh?
Yes.
Okay, going forward, the next thing that you need to know here is, so the first thing was introduction of surds, which you have a fair enough idea that if I write any real number and if
Mm.
if I use an operator, which here it is square root, it becomes a real number along with the square root becomes a real surd. That is something that we have understood in the last 5 minutes.
Yeah.
Okay, next 5 minutes, we will focus on what if I want to use mathematical operators between two surds. So for example, this is the first one, this is the second one, this is the third one, this is the fourth one. So now if I talk about the first one and if I say square root of 2 added with square root of 3, is it still a real surd? Yes, it is. Taking this forward, and if I say square root of 2 minus square root of 3, is it a surd? Of course it is. If I
Mm-hmm.
say square root of 2 into square root of 3, is it a surd? Yes, it
Yeah.
is. The last but not the least, if I say square root of 2 divided by square root of 3, is it a surd? Yes, it is. That means what, which kind of a surd is this? This is a kind of extension of a pure surd. Why do I call it as a pure surd? I would write it down here. Maybe after this session, you can make your notes as well. We are talking about pure surds. So this is a pure form of a surd. Why do I call it as a pure surd? Because if I take one surd, which is a real surd, I use a basic mathematical operators. We know that there are four basic mathematical operators: addition, subtraction, multiplication, and division. And I use these mathematical operators with another surd which is either equal to the same surd or a different one. Then it becomes a pure surd. Pure surd means any representation which is represented under the roof of a root with the help of mathematical operators in between. Makes sense?
Mhm. Could you go over it one more time, please?
Yeah. So what I'm trying to say is, let us take the first example, square root of 2 plus square root of 2. Or I take square root of 2 plus square root of 3. So we have basically taken two equal surds or two unequal surds, right? And I'm having a basic mathematical operator in between, which is addition. Now, when I do this, the resultant becomes a pure surd. Meaning thereby, if I take an individual surd, which is root 2, I take another individual surd, which is either root 2 or root 3, and if I use basic mathematical operators like addition, subtraction, multiplication, division between them. I hope you are aware of the fact that the word between is used for exactly two things.
Yeah.
Yeah. So now between two surds, whether they are equal or unequal, if I use mathematical operators, basic mathematical operators, the resultant is a pure surd, is what I said, which is why I wrote it as pure here. Maybe if you're
Mm.
making notes, you can make a note as these all four representations are representations of pure surds.
1 second. My pen ran out of ink.
Yeah.
Hmm?
So now
Yeah.
in the final 5 minutes, or let us say, so we will talk about impure surds. So see column number 2 and the segregation. So I'm not talking about square root of 4 because it is a pure surd. Why it is a pure surd? Because it's only written under the roof of a root. Now, when all these, so if I take only square root of 4, it is a pure surd. If I take square root of 2 plus square root of 3, no doubt it is a pure surd, but we call it as a mixed one. Now, why I call it as a mixed one? Because there are two things here, and both the things are pure surds. Meaning thereby, we are now, if you recall in my earlier sessions also, we have been talking about the concept note of Shiksharthi. And the concept note of
Hmm.
Shiksharthi is we make you think on the basic things first, then we want you to reason it out, and then we want you to refine it. Refinement comes only when you think, you reason out, and then you take it to a next level, which is refinement.
Okay.
So now if there is a question, if I were to make questions out of the last 10 to 11 minutes of discussion that I have done with you, and if somebody is interested in knowing, are all mixed surds pure? The answer is no.
Okay.
I repeat,
So
I repeat. If there is a question and the question is, are all mixed surds pure? Then what
no.
do you need to think here is a mixed surd. Let us say that there are two things that you are mixing. One is A and the other
Hmm.
thing is B, and you are using a mathematical operator of plus in between. Now, when will I call this as a mixed surd? I'll call this as a mixed surd only when one of them, I mean, one between A and B should be a pure surd. For example, I can put the value of A as square root of 2 and B as square root of 3, right?
Yes.
So it's a kind of a mixed surd, which becomes a pure one because both A and B are the purest forms of surd. Vis-a-vis, if
Oh,
I take this example, vis-a-vis, if I take an example like 2, I put the value of A as 2, but then I put the value of B as square root of 3,
then it would be
right?
impure.
And correct, absolutely correct. But still, it will be called as a mixed because for a mixture, you require at least two things, which is A and B. So, answering the question, which is the question here was, are all mixed surds pure? The answer
No.
is they may be pure, they may be impure. But if there is an affirmative statement, how will you answer an affirmative statement if it is a 50-50? So you will say, no, not
No.
all mixed surds are pure. I hope you got
Yeah.
it.
Yeah.
So what are we doing here? We started off with the basics in the very first 10-11 minutes, which is giving you a think tank, right? And then
Yeah.
taking it to a next level, which is having an element of reasoning. So you would see in the second column, I have used the same basic mathematical operators to take your learning to a next level. And just using those four basic mathematical operators, what have I done? I have formed four different impure surds.
Hmm.
Now, the next question which comes up here is, why do we call them as impure? I hope the answer becomes quite obvious because this 2 has not been written under the square,
Root
under the
of.
roof of a square root,
Yes.
which is why you will decipher the answer with the help of the presentation. So if I talk about what is 2, is it an integer?
Yes, it
Yes,
is.
it is. So a surd cannot be an integer, a point to be noted by you. A
Yeah.
surd cannot be an integer. Can an integer be a surd? Not at all.
So, what do you mean by like that? So when you like find the square root of the surge, just if you do like the square root of 3,
Yeah,
the answer of that can't be an integer. Or
absolutely correct. Bullseye.
okay.
But then finally, I mean, now let me take it to the level of refinement. So we started off with basics, right? We
Yes.
introduced what is a surd. We understood. We are talking about only real surds for the time being. Do we have non-real surds? Of course we have, but we are not discussing it because it is outside the domain of the discussion as of now. right? So we started off with real surds, then we talked about pure surds, we talked about impure surds, we talked about mixed surds, right? So what are we doing? I mean, we are trying to familiarize ourselves with surds. I mean, what exactly is a surd? Now, taking it, so I gave you, and then we reasoned it out also in terms of making some tongue twisters or questions which are difficult to maybe understand with an element of reasoning. Are all pure surds mixed? Are all mixed surds pure? Maybe other questions which you can write down as a byproduct of this discussion, which henceforth you can take it up yourself. I hope you'll be able to answer it. But
Yes.
then let me give it a small twist now. And the twist here comes from this discussion, square root of 4. Can you tell me what is the value of square root of 4?
2.
Okay. Can I put it as plus 2?
Yes.
Okay. So please remember square root of 2 square root of 4 will always give you a positive answer. The answer of this can never be equal to a minus 2. Please make a note of it somewhere.
Uh,
Meaning thereby, when you are taking the square root of a positive real number, when you're taking the square root of a positive real number, the answer will be a positive real number.
hmm.
So I'm writing it down also, as you could see in real time. Square root of plus r gives me plus r, let's say another r dash. This is very, very important as a byproduct of this discussion. And please, I hope by now you would have understood, we have had some sessions together. This byproduct is very important because this comes as a corollary. When you're learning something and when you move from the one step to the other step, it may yield byproducts, which are very important.
Hmm.
Having said this, now the moment I write square root of 4, I know that square root of 4 can give me an integer. But if I only talk about square root of 4, and if somebody asks me a question, what is square root of 4? You will say this representation is the representation of a surd. But the moment it is said that if square root of 4 is equal to plus 2, then plus 2 is not a surd. Do I come back again?
Yes.
So if somebody asks you, hey, Pransh, tell me that square root of 4, is it a surd or is it an integer? What is
It's
your
an,
answer gonna be? You will say
it's
it
an,
is a surd. Why? Because we know that the definition of a surd is a real number written under the roof of a root. I mean, I know that square root of 4 can be written as plus 2, but at the moment I'm only focusing on this. I am not focusing on this. So whosoever is asking you a question, the question here is square root of 4 a surdial representation? The answer is yes.
yes.
But if the question is square root of 4 is equal to something, now that something, is it a surd? No, it is not, because square root of 4 is equal to is equal to a plus 2, which is not a surd because it is an integer. Please understood, this is the level of refinement.
Yes.
And we call it as higher order thinking skills, HOTS. So higher order thinking skills is when you start off from the basics, you take it to a next level, you take it further to a next level, you keep on taking it to a next level, which is the higher level, is when we call it as a higher order thinking skill.
Okay.
Yeah. Now, as a byproduct of this interaction of around 22 minutes with you, if you have any questions, please ask.
Not really. I think I've understood uh it all actually.
Okay.
Is
So, I mean, was everything clear, or you came across something? Was it explained properly to you, etc.?
yes, yes, 100%.
So tell me, what is something that you found it interesting in the last 22 minutes?
Um, the you know where you put the operationals, sorry, the mathematical operations in between, and how it can always equal, how that actually counts as a surd. Because I never knew that, but now I do.
Okay, you know it now.
Yeah.
What other than that you found to be interesting or maybe uninteresting also?
Um, I don't think I can say it wasn't interesting. All of it was interesting, but it's hard to pick out like the parts that really interested me because it was all quite interesting and the concept was very easy to understand. Well, the way you explained it, my teachers explained it slightly differently, which it was a bit confusing. But it's like with the um, multiplication we went over, like two-digit multiplication. It's taught very differently here. Um, but like your way is quite simple to understand once you get the hang of it, and very quick as well. So I think, uh, yeah, it was similar to that, basically.
Okay, Pransh, as an epitome to this discussion, what I would want is my whiteboard still visible to you?
Yes.
Okay, now let me talk about this. Let me focus as a final discussion. Let me talk about these two.
Okay.
There is a reason why I have chosen these two, and there is a reason why I have chosen these two. So I am putting a double arrow for the ones that I have chosen. I hope you can see both of them. The
Yes, I can.
first the first one that I have chosen here is square root of 2 plus square root of 3 along with square root of 2 minus square
Two
root of
minus
3.
square root. Yeah.
And the next one that I have chosen here is an impure form. And remember these pairs that I have chosen. Look at them as a pair is what I want to highlight.
Okay.
Now, why have I taken them as a pair? Because such pairs are known as conjugate pairs.
Oh, okay.
You can write it down.
Wait, so could you do the same thing for minus and divide, or not?
Yeah, you can, but let us have a very basic discussion on this. A very basic discussion that I'm trying to do here is if I take both these pairs, the pairs that I have taken, so these pairs will be known as conjugate pairs. So let me make a formula out of this. And what I'm trying to highlight here is if I take square root of a along with square root of b, let's say square root of a plus square root of b, right? And at the same time, I take square root of a minus square root of b. They will be termed as conjugate pairs. If you can just write it down.
Yeah.
At the same time, if I merely take a along with b, let's say a plus square root of b, or if I would have taken a minus square root of b,
Yeah.
both of them. So you already have an example. For example, a here is 2 and b here is 3. So 2 plus root 3 along with 2 minus root 3 will be called as a conjugate pair. Analogously, square root of 2 plus square root of 3 and square root of 2 minus square root of 3 will be known as conjugates. They are conjugates to each other. Why are they conjugates to each other? Because when they are multiplied with each other, I mean, when both the conjugates are multiplied with each other, they do not result into a surd. They result into a rational number.
All right.
I'll repeat. If I multiply, let us say if I multiply square root of 2 plus square root of 3 along with square root of 2 minus square root of 3, I can use the formula a square minus b square. I know that a plus b into a minus b is equal to a square minus b square.
Yes.
Now, in that case, a is square root of 2, the square of which is 2. B is square root of 3, the square of which is 3. So it results into 2 minus 3, which is minus 1, which is a rational number. Meaning thereby, the point to be learnt finally is a surd is an irrational number. You may write it down. A surd is an irrational number. Irrational. And at the same time, you can say an irrational number is a surd. So the converse of this is also true.
Okay. So
This I'm just giving you some food for thought. I mean, you need to think
oh,
on this. And then what I said was, if two conjugates are multiplied with each other, for example, if I multiplied 2 minus root 3 with 2 plus root 3, it is going to give me 2 square minus 3 using the formula a plus b into a minus b, which is algebra.
yeah.
So in that case, 2 square minus 3 gives me minus 1. I'm sorry, it gives you plus 1. So in both the cases, when I multiplied two conjugates with each other, they gave me an integer, which is a rational number. So when two conjugate surds are multiplied with each other, and we are basically talking about real surds, real number surds, the resultant is a rational number. From here, we are able to prove that the discussion on surds is nothing but it is a kind of a progressive learning starting from numbers, and in between you come across even other topics like algebra, etc., which facilitate the discussion on surds.
Oh, okay.
Make sense?
Yes.
So I hope this refreshes you for the entire day today.
Yes, it does.
Yeah, I hope I think this is all that we intended to discuss. Is there anything
Yeah.
that else other
Could
than this that you would want to ask?
so no, my only question is how so say you got a surd, such as two oh no, sorry, don't worry, don't worry.
No, please
I
ask.
understood.
I mean, you can ask anything.
Oh no, I've
If you,
understood it. I've understood it. Don't worry.
hmm. Okay. So, anything else that you would want to ask before we call it a day for this session?
No, I actually think I've understood everything, which is
Okay.
surprising
So,
to me
yeah.
because
So
I didn't think
now,
I would understand it.
yeah. So now, as a homework, I would suggest there should always be a homework which makes you move to the next step. As a homework, maybe what we'll do is we would want you to go through the discussion on numbers that we have done. So maybe we'll send the link to you, the website link, and go through numbers. That will help you a lot to facilitate your learnings on numbers
Okay.
so that you can take it to a next level. Make sense?
Yes.
So goodbye then.
I'll see you when we next meet.
Yeah. Okay. Bye bye.
Bye.